We're looking at section 10.4 because when we graph quadratic equations, sometimes the visual of the graph communicates more than just a bunch of numbers. So we want to know how to graph these. Now in graphing these, we're going to use the basic formula y equals ax squared plus bx plus c. And what we want to figure out is what happens to be our vertex point in our graphs. So we're going to use another little formula, which is x equals negative b over 2a. I'll show you how we use that. If we would, let's go ahead and turn to page 732 and look at problem number 4. In number 4 it says y equals x squared plus 3. Alright? So if we use this x equals negative b over 2a, the b value is missing, so that's negative 0 over 2 times 1. And 0 over 2 is equal to 0. Therefore, if there is no x term, as there isn't in number 2 on page 731, or number 4 that we have here, what that means is our vertex actually is going to be right along the y-axis. But let's take a look at one where we do have a b term. So let's erase what we've got here, and let's go ahead and take a look at problem number 6. In problem number 6, we have y equals x squared plus 2x. Now we do have that b term right here. So we can plug that into our formula. X equals minus, and our b term happens to be 2, over 2 times 1. So x is equal to negative 2 over 2, or negative 1. So you say, okay, what's the point of that? Well, what that does when we go to plot is we'll have x and y coordinates, and we need to have 5 of them. What we do is when we get that vertex point, x equals minus 1, we put it right there in the middle. Then we surround it by numbers going higher and lower. In this case, that would be 0 and 1, and negative 2, negative 3. Now once we've done that, we go ahead and plug our values for x into our formula, or our equation. Y equals, and it's 1 squared plus 2 times 1. That's y equals 1 plus 2, and that's equal to 3. So that's a 3 down here. Then when we take y equals 0 squared plus 2 times 0, that is y equals 0 plus 0, which is 0. And our third one, y equals negative 1 squared plus 2 times negative 1. Now we get y equals 1 minus 2, or minus 1. In our fourth one, where we take y equals negative 2 squared plus 2 times negative 2, what we get now is y equals 4 minus 4, and that's 0. And finally in our last one, where we have y equals negative 3 squared plus 2 times negative 3, we'll get y equals 9 minus 6, and that's 3. So we had to do a lot of work to get these, but if you'll notice, what we've got here, with that negative 1, we got our low point here. But the y values, you'll notice that the y value for our first term, 1, and the y value for our last term, negative 3, are the same. There's balance there. The y value for the second term and the y value for the fourth term is 0. So now what we've got is we've got the points we can use to plot our quadratic equation. The first one is 1 and 3, so it's x is 1 and y is 3, and that's up there. Second is 0, 0, that's right at the axis. The third is -1 and -1, so that's there. The fourth is -2 and 0, and then the fifth happens to be -3 and 3. And then when we go to plot that, what we're going to do is we're just going to connect these. And you'll have to freehand that. But our vertex is that point where it's at the lowest, right there. And there is our first graph. Now obviously mine is not nearly as neat as what you'll see in the book. But let's take a look at another one. This one's going to be a bit more challenging, and I'll explain to you why in just a second. I'm going to try and erase what we've got here. And I'll have to freehand in some of our points, the graph, because I've lost some of the points here. Come across like that, down like this, and then we got -3, -2, -1, and then we have 3, 2, 1, and we've got our graph back. So let's erase number 6. We've done that one. We want to keep that little simple equation x equals -b over 2a. And let's go ahead and take a look at problem number 12. Number 12 is interesting because with number 12, what we have is y equals x squared plus 3x minus 4. Okay? Now, having that, why don't we go ahead and figure out what that vertex point is for this quadratic equation using x equals negative, and b happens to be 3, over 2 times a. When we do that, what we get is negative, and I'm sorry, 2 times 1. That a should be a 1, because that's -3 over 2, or -1 and 1/2. Now, starting to surround that point with other points might be a little difficult. So if we set up our xy parameters, we have 5 of them. Now, instead of putting that one right in the middle, what we can do is we can surround that with what's one that's a little bit less than that or greater than that would be -1. Then we'll have -2, -3, and -4, and we'll have 0. All right? Now they're not all going to balance out because we know our vertex is -1.5. But let's go ahead and take a look at if we plug these in. In the first one, y equals now 0 squared plus 3 times 0 minus 4. So that's y equals 0 plus 0 minus 4, and that's minus 4. Minus 4. If we have a use of -1, y equals -1 squared plus 3 times -1 minus 4. This is y equals 1 minus 3 minus 4. In that particular case, now 1 minus 3 is a -2, minus 4 is a -6. In the third one, where we're using, I'm sorry, we'll have to put that in there, -6. Y equals -2 squared plus 3 times -2 minus 4. Y is equal to 4 minus 6 minus 4. So y then is equal to -2, 4 combined with -6 makes it -2, minus 4, that equals -6. In the next one, we're going to use -3. Y equals -3 squared plus 3 times -3 minus 4. So y equals 9 minus 9 minus 4. 9 minus 9 being 0, that's minus 4. And our last one, when we use minus 4, well, minus 4 squared plus 3 times minus 4 minus 4. That's y equals 16 minus 12 minus 4. And that turns out to be 16 minus 12 is 4, minus 4 is 0. When we go ahead and plot those points, and I forgot to put this minus 4 here, and then 0. We'll go ahead and plot those. The first one being x is 0, y is negative 4, is clear down here. X is minus 1, y is minus 6, that's down here. And x is minus 2, y is minus 6, that's here. And x is minus 3, y is minus 4, that sits up here. And our last one, minus 4 and 0. And I suppose if we used 1, we would probably find out that 1 squared plus 3 times 1 minus 4. We can do that very quickly if we want. Sorry about that. We'll just do it right up here. We could plot this 6th point. We don't have to do that, but we will. Where we have plus 1, y equals 1 squared plus 3 times 1 minus 4. Y equals 1 plus 3 minus 4, and that equals 0. So we know that if x is 1, y is 0. That's this point up here. Now we see we have this graph, and it comes down like this and goes through this point. But the apex, as we recall, was right here. Okay? So where x is minus 1.5, and so this bends in between those two dots and then comes back up like this and is graphed like that. Okay, I want to take a look at one more problem and then we're done. Looking at problem number 16. And I'm erasing everything to include, unfortunately, my x equals minus b over 2a, but we can put that back up here. Sorry about that, x equals minus b over 2, not a 3, a 2, over 2a. If we look at number 16, what we have with 16 is y equals negative x squared plus 2x. And so plugging that in, x equals minus 2 over 2 times minus 1. This equals negative 2 over negative 2, and that is 1. So when we set this up, x, y, and we have these 5 points, our middle point is going to be 1. So this would be 0, and this would be, I'm sorry, let me try that again. That's going to be 2. This is going to be 2, and that's going to be 3. There's going to be the 0, and then minus 1. And we should get some balance there. All right? So let's go ahead and try that. Starting with y equals negative 3 squared plus 2 times 3. So y equals negative 9 plus 6, or it happens to be equal minus 3. In the second one, where it's y equals negative 2 squared plus 2 times 2, y is then equal to negative 4 plus 4, or 0. In the third one, where it's y equals negative quantity 1 squared plus 2 times 1, then y is equal to minus 1 plus 2, and that is equal to 1. In the fourth, where it's y equals minus 0 squared plus 2 times 0, that's 0 plus 0, that's equal to 0. And finally, in the last one, y equals minus the quantity minus 1 squared plus 2 times minus 1. Y is equal to minus 1 minus 2, and that's minus 3. And again, we've got that balance. The endpoints, the y value is minus 3. For the next two, the y value is 0, and at our apex, it's 1. I'm going to quickly erase our graph, or the major portion of our graph. Can't erase all of it, but I'm going to erase that, because what I want to show you is what happens when we plot this other graph. If x is 3, y is minus 3, so it sits down here. But when x is 2, y is 0, so that's right here. When x is 1, y is 1, so that sits right here. When x is 0, y is 0, and then when x is minus 1, y is minus 3. And you see, as we graph this one, it goes up like this, peaks, and then comes back down again. That's different from our previous graph, which came down to a point here and then went back up. You can tell that because the x squared term for number 12 was positive. The x squared term for number 16 was negative. And therefore, if it's positive, you'll get a graph that dips down and comes back up. But if it's negative, you get a graph that looks sort of like a hump. That should be enough for learning how to do these once you have the basics there. I did demonstrate number 12 for a reason, and that is when you get a fractional form for your apex point or your vertex point, what you want to do is pick numbers on either side, and maybe you'll want to graph 6 of them.